Hello YouTube. So for today we are going to cover this 2779 question on LeetCode. So this is basically maximum beauty of an array after applying operations. So we are given an array nums and a non-integer k, and what do we have to do? We have to do some operations. We have to choose any index and we can replace that index with nums of I minus k to nums of I plus k range. So this is a range basically, and we have given an array nums and k. So what do we have to return? Basically, the beauty of the array is the length of the longest subsequence consisting of equal element. So we have to return the maximum possible beauty of the array. So notice one point here, we have given we have to return this longest subsequence consisting of equal element. So this is the main point of this question. Now if you see on one example, we have given 4 6 1 2 and we have given k is equals to 2. Now we can replace index 1, that means this 6 with either 4 or 8. I mean in the range of 4 to 8. So we are selecting 4 from here, so that makes 4 and 4 1 2, and then we can replace this fourth index, that is 2, from 0 to 4, and we'll select 4. So that makes 4 4 4, which is the longest common subsequence in this case. So we'll return the output 3. Now let's jump onto the solution and intuition part. I'll explain you more clearly what the question is asking about. So yeah. Okay. So now let's jump onto the intuition part. So what we have given basically, I'll draw here. Yeah, so we have given a nums, and let's say this is of this list 4 6 1 and 2, and what we have given k is equals to 2, let's say, for this case. Okay, so now what we have to do, we have to find out the longest common subsequence within this nums. Okay, so now 1 2 3. Okay, so now let's jump onto the intuition part. So what we have given a nums array of some elements, and we have given k. Okay, so now let's jump onto the intuition part. So what we have given a nums array of, let's say, 4 6 1 and 2, the elements are, and we have given k is equals to 2. Now what we have to do, we have to find out the longest common subsequence within this range, k is equals to 2. I mean, if we select any of this index, we can do 4 plus 2 to 4 minus 2. That means the range would be somewhere around 2 to 6. So we can select any element from there, and we have to find out the longest common subsequence. So now let's see the range first. Range from the nums. So we can take from the minimum element, that is 1, to the maximum element, that is 6. So now let's say if we take this 1, so in this 4 6 1 2, if we have taken 1, so now 4 minus 1, that makes 3, and 3 is greater than 2. So we don't need to consider 4. So if we are taking 1, then 4 is not considered. Okay, and then if you are taking 6, again it is too far away from k, so that is also not considered. 1 is considered, so we can write 1 and then 2. So this would be the size for 1. Now if we take 2, then what would happen? Then 4 minus 2 makes 2, and 2 is greater than equals to 2, so we can consider 4. Then 6 we cannot consider, then 1 we can consider, and we can consider 2. So this is the size and of 3. This would be of size 2. Okay, so I mean, this is the longest common subsequence in if we select this 1, if we select this 2. Now if we select this 4, the longest common subsequence would be 4, 6, and then 4 minus 1 makes 3, which is smaller than k, so we cannot select 1, and we can select 2. So the maximum size would be 3 in this case. So we have to return 3. This is the main intuition behind this question. So we have our brute force solution, but since the constant are too large, so we cannot use it. So now let's see what is the optimized solution for this. So that would be using sliding window. Now how? Let's see. So we have given this array, let's say I'll write it again, 4, 6, 1 and 2. Now how I will apply this sliding window is basically, if you notice, if we pick any element, we can choose from, if you, let's say if you have chosen 4, we can either go to 4 plus 2, or we can either go to 4 minus 2. Okay, if we have selected 6, we can either go to 4 plus 6, or 6 plus 2, or 6 minus 2. See, this would be the range of this. Okay, now and let's say k is equals to 2 over here. So now we can see that k either go to 2 step back, or either go to 2 step front. I mean, so this is doing a coverage of 2 into k. If you can see the coverage, so that would be somewhere around 2 into k. Now for every element, if we do like, let's say for 4, so if we just subtract from the next element, I mean this would be 6 minus 4, and let's say we have selected 4 this time, and if we can check if this is less than or equals to our k value, or 2 into k value, because the coverage is from both sides. So 2 into k, that makes 4, because 2 array k is 2 in this case, so that makes true. So we can select, for 4 we can select 6, so this will give that we can select. So this is the base condition. Okay, I'll write it down more clearly. So the base condition would be a of this array of j, that means the right pointer, minus array of I, that means the left pointer, is not equals, is less than equals to 2 into k. Okay, so if this is the case, then we have to move our window. Now let's say just assign window count to 0, and let's say a max length to 0. Now for this example, okay, so first of all we sort this array. Why? Because of like we can do just adjacent subtraction, and that makes more sense. So first of all we do sorting, and then k would be 2. Okay, so this would be the sorted array, and now we'll see. So we'll see if we'll see start with 1. So for I is equals to 0 to nums dot length. So we have to make this right pointer. Let's say this I is the right pointer. So right now this I is here and this j is here. Okay, so let's say if this I is the right pointer, then we have to move I until the nums of length, and we have to increase j if, only if this condition works, that I've already written down, a of j minus a of I is less than equals to 2 into k. Okay, so if this is the case, then we have to increase this j value. So j is the left pointer, I is right and j is left pointer. We have analyzed board to 0. Now let's do a dry run and we'll see how this window is working. Okay, so 1, 2, 4, 6. Now I is here, j is here. Okay, now we see, now we have 1. Okay, so for 1, let's just increase the window count to 1, because we know a of j minus a of I, that makes 0, which is smaller than so 0 minus 0 is smaller than equals to 2 into k, that means 4. So window count will be increased to 1, and max, max length we have is 0. Okay, now so this window count is increased to 1 and this j will pass to 2. Now sorry, this I, because I is the left pointer, right pointer. Now I is 2, and if we do 2 minus 1, that is also less than equals to 4, then we'll increase the window count, then we'll again move our I forward. Now 4 minus I, 4 minus 1, that makes 3, which is also less than equals to this, so this would be 3. Okay, let me remove this, and now we'll jump on to 6, and this 6 minus 1 is not 6 minus 1, that makes 5, which is not less than equals to 4. So that makes that means we have to reduce, that means we have to shift our j pointer to here, I mean one index further. So now the j pointer would be shifted to the adjacent element, and the window size would be decreased to 2, because if you see, I is here in the 6th element and j is here in the 2nd element. So now we consider, okay, so since the I reaches here, now this will again check, basically 6 minus 2, that makes 4. 4 is less than 4, so we'll just increase I, and it will pass on basically. So that is the end of the case. And also if we reach this case, I mean where we are decreasing the window count, so we can update the max length value. Okay, and we can update the max length value, update max length when a of j minus a of I is greater than 2 to the power, 2 multiplied by k, and also shift left pointer. Okay, so this is this case, and maximum of 3 and 2, that makes 3, so we'll return 3 as an answer over here. So this was regarding the intuition part. I'll show you the code also for this one, that makes more understandable regarding this problem. Yeah, so this is the code. Now we have assigned this window count as 0, we have assigned this maximum length as 0, we have assigned this left as 0, as we start left from 0. We'll sort these nums, and then we have we have put a for loop to right equals to 0 to nums dot length. Now we'll see while nums of right minus nums of left is greater than 2 into k, so that means that this case is failing, and we have to increase the left pointer, and we have to decrease the window count, as I've also already told in the notes. And then what we have to do, we have to increment, like if this is not, then we have to increment this window count, and we have to select the max length, which is max length of and window count. So this will give me the answer, max length. And yeah, so this could be the desired output. And if we talk about the complexity of this, so this would be somewhere around big O of n log n. Why? Because we have used this sorting, which cost me a lot of complexity, so that makes log n, and this n because we have traversing the array once. This is about the time complexity, and the space complexity would be constant, because we haven't used any space. So yeah, this is regarding the complexity, and yeah, I hope you understand this problem, and yeah, that's all. Thank you. Please make sure to like and subscribe. Thank you. Have a nice day. Bye bye.